which are controlled or operated through artificial intelligence. Okay, I will give you thinking. Right? What is artificial intelligence? So basically, the machines which can make decisions on the basis of given scenarios. Right? Machines or algorithms which can make decisions on the basis of the given scenario. That is artificial intelligence, right? Okay, these are the things which you just listed. Okay, you don't need to monitor or track them while they are telling you different things. Okay, while they are performing their functions, you don't need to go and track each and everything. Okay, for example, these slides. If I finish talking, they still remain the same. Okay, but if I can program something, then I stop talking. The slide should change. This is artificial intelligence. Okay, and now this area has become very popular. Okay, so I will come back to this picture. So you already mentioned some of the things. Now they are making robots which can perform different operations. Okay, they are using for gaming as well. They are using it in factories and different plants and industries. Okay, we have smart cars. Okay, which can perform different functions for us. Radars or drones. Yeah. Okay. So obviously, someone is controlling their direction, but their trend, the way they move, is not controlled by anyone. They take their own decisions. And then this is again some the industries which are using equipments through sensors. Okay, and the equipments are performing their functions. Okay, without any supervision. And then again, this is a more general picture of what we have around us. Okay, like the laptops, our homes, shopping, and our cars. Okay, the satellites and cell phones and so on. So now the range of artificial intelligence has gone from the top level, which was for the industrial use, to our daily life. Okay, so it has now grabbing a lot of significant proportion of our life, and this portion or proportion seems to be increasing day by day. Okay, the more we are relying on things, those are all related to artificial intelligence. Some of the techniques which we use, which are called under the umbrella of artificial intelligence, they include genetic algorithm, particle swarm optimization, support vector machines, artificial neural networks, about which we will discuss in detail. Okay, have you heard about these techniques? Okay, so can somebody tell me what is common in all of them? Who have heard about these techniques? You and? Okay. Do you know enough? What is common in all of them?
Optimization, prediction.
Okay, that is not common.
Algorithms.
Computer-based algorithms.
Yeah, computer-based algorithms. Okay, what else?
I think the first one and the last one is based on human being.
Very close. Okay, anything else? You all of you are correct. Okay, but the point to which I am trying to go is they are all depicting natural intelligence. Okay, one form or the other. The genetic algorithm, basically they are based upon the principle of natural selection, right? The strongest genes should win. They have a big theory about it. Okay. Particle swarm optimization, again, similar. The birds, yeah. Okay. Then we have support vector machines. I don't know myself, but they are.
Something with the nature.
Yeah. Okay. Artificial neural networks. Obviously, this directly comes from the working of a human brain. Okay. And then there are other techniques as well, like ant colony optimization. Okay. And we have bee harmony function. Okay. So all of them are trying to capture what intelligence is naturally available, and then they are programming it in the form of a computer algorithm. Okay, so whatever we found, we are using it for our own benefit. Okay, so whatever this thing is doing in nature, we want it to do something for us in terms of programming, in terms of optimization, in terms of forecasting. Okay, but all of them are one form or the other, some part of natural intelligence which is already around us. So, subhanAllah, this is the beauty of nature. Okay, that we are progressing, but we are still depending upon the things which we have. Okay, so why do we want to, how did we come to the conclusion that we should focus on capturing the essence of natural intelligence? Okay, so the first thing is,
Evolution.
in nature, things evolve. They don't remain in the same state. So this gives us flexibility. Okay, so you write a computer program which, for example, calculates the inverse of a matrix. That program will keep on doing it, the same thing. Okay, but if somehow this program can evolve to do other different functions of the matrices, then this is much more beneficial, right? And this is what we do. So, like the kids, you teach them what? A, B, C, D, 1, 2, 3, and then they go on for different functions, okay? Addition, subtraction, okay? Then spellings, then grammar, okay? So, if we keep on feeding them, they will evolve. They will start, doing more things which were difficult for them earlier, okay? So, the one thing is, in nature, things evolve, okay? And you may have heard why dinosaurs died. Said they could not evolve. So when the world changed, they had to die. They could not afford. So, but most of the things in nature, they evolve. Okay. Even a single species during the lifetime, it evolves. Okay, which you can see here. Okay, and then the second thing is learning. Not only they grow, they also learn about different things, and based upon their experience, so they gain experience. Okay, so evolution is something related to their nature. Okay, learning is something related to their intelligence. Okay, so they experience different things, and when they are making the next decision, the previous experience is used. Okay, so these are the two main items because of which we try to capture the natural intelligence. First of all, you can, if you have something which can evolve, okay, so this gives you a lot of chance to do different things with the same algorithm, okay, or the same tool. And the second thing is learning. Okay, so while it is learning, then it is whatever bad decisions it has made, you are sure or almost sure it will not do it again. Okay, so a machine malfunction because of a sensor issue. Okay, this is something it should have learned. Okay, if it keeps on doing the same thing, that means there's a problem with the learning, right? Yeah? Okay, so these are two things because of which we try to capture the human intelligence. Okay, before we go on again to the explanation of the neural networks, let us have a live demonstration. Okay, so you see 10 numbers in front of you. Okay, can you guess the next number? Anybody? Huh? 14? Okay. Huh? 15? 15? How many say 15? 2 and 14? 2 and 2. Huh?
14.
14? Sure. You can say something else. You can say 1402. No problem. Huh? Sure.
14. I will change to 16.
16?
Yes.
Okay. 16. Okay. So let's say these numbers are from, so you gave me different numbers, right? 16, 14, and somebody said 15 as well. You said 15. 15 and 14 and 16. Okay, so I have 3 numbers. Okay. And they are coming from different people. Now, let's say one of you is an expert. Okay, expert in the field from which the data is coming. Maybe it's the stock market data, maybe it's the weather data. But one of you is an expert. Okay, and let's say you are right. You did your PhD. You are an expert. expert in everything. Okay, this is like career advice. Now you feel like you are an expert in everything. Okay, they cannot give you any other degrees. So you are an expert. So let's say since this guy is an expert, okay, so from the numbers which I had, I put more weightage on his response as compared to others. Now let's say I am the manager of the team and my boss is asking me what will happen next. Okay, and I have to give him some answer which doesn't embarrass me. Nobody knows the future, right? Nobody knows the future. I cannot be 100% correct. Okay, so what would I do? What would I do? I have 3 responses from different people. Okay, and one of them is an expert in the field, and the others also are, somewhat specialized in the field. So, what would I tell my boss? What number would I give to him if I'm smart? Remember, we are talking about artificial intelligence, right? If I'm smart enough, what would I do? I'm not looking for a 100% answer. I'm not looking for 100% accuracy. I just don't want to be embarrassed. Something comes in the future, and you shouldn't tell me you were telling me this, and the number is, the actual number is way beyond what you were telling me. So you don't know anything about your job. So, if I'm smart enough, what would you do?
Yeah. You can assign a weight for each person based on his experience, how much you know about that.
Yes.
And then you take the final answer based on the weight. Like, for me, 60% you will take from my answer. And like this for them.
Yeah. So, you see, this is what the neural network does exactly. All of us were different units in the neural network system. Okay, this is what we call as the input data. You got this data, you processed it. Okay, then you give me different answers. Okay, you had your own reasons for giving me 15 and 14 and 16. I am the unit which is taking all the answers and then giving it to the user. Okay, the one who is using the neural network. Okay, so each one of you, now let me go to the so each one of you was a processing unit, and that processing unit is called as a neuron. Okay, and this is the same terminology which the doctors used for the processing cells in our brain. Same, no change. Okay, so each one of us or each one of you was a neuron, and you were taking the same input, you were processing it, okay, and then you were giving me the answers. Okay, so this is what I gave you. These are you, and this is me. Okay, so what did he just say? I will take the answers from each one of you. Okay, I will process it, and whichever is, whichever should have. So I will process it, and I will assign it different weights. Okay, and then I will take a weighted average. Okay, so this is what the neural networks do. Okay, so eventually what will happen? So I take 16 and 14 and 15, and even if I take a simple average, it will be what? 15, right? 14, 15, 16. Simple average is 15. If I assign more weight to 16, it will be 15 point something. Okay. Now let's say the actual answer was actually 15. Okay. So if it was 15, 100% match. If it was 15 point something, you are only off by fractions. In a magnitude of 15, you are only off from the real answer by fractions. Okay, so this is working. This is why neural networks in 90% or 99% of the situations, they look very accurate. Okay, because they have so many units to work with. Okay, and they are getting the answers in the end like a weighted average. Okay, So maybe one of the answers was like way out, but when you take them together, okay, when you take them together, that one answer is not shown to you. Okay, when I take all these, so maybe this one, this particular guy, I wanted him to be there, but he refused. So I mean, this particular guy was saying 100. Okay, but again, when I take the average and I have 10 different values, even with this 100, I may get actually an accuracy of 80% or 90%. Okay, so this is how the neural networks work. They will take the inputs. So each unit in the input layer, so they have 3 layers: input layer, the hidden layer, the output layer. Okay, input layer is what? The data which you have. Okay, now I gave you data which were 10 points, right? And that was basically a sequential data. A sequential data. Another type of data can be that we have samples, and with each sample, you have some input variables and some output variables. Okay. In that case, this will be one of the input variables. Okay. So this is input variable number 1, number 2, number 3, and so on. If you have 10 input variables, you will have 10 units. Okay. But these input variables are not doing much. They are just feeding the data. So all these input variables go to each of the processing units, and these processing units are known as hidden neurons or hidden layer. Why hidden? Because input I know, output I'm getting. This one is not for the user. Obviously, if you are the programmer, you know what is happening in the hidden layer. It's not hidden from you as a programmer or as a developer. Okay, but for the user, it's hidden. The user will say, okay, input is this, and the program will give him the output. Okay, so all these inputs will be taken by each processing unit. Okay, so since in your example you were processing it, what you were thinking, I don't know. Okay, so this is why we call it hidden. Okay? And then we have the output layer, which is the answer you were telling. Okay, but the output layer, as I said, it is getting multiple answers. So it needs to process all the answers. It will take all of them. Okay, maybe apply a weighted average, and then there are other functions as well. It will apply some sort of processing and it will give you the answer. Okay, clear? Okay, so this is what I already. Okay, so each processing unit is taking multiple inputs. Okay, so it will take the inputs, all the inputs, and then it will apply some weight to each input. Okay, and then it will take the weighted summation. It will add constant. Okay, you call it error constant, and there are other terms as well. Bias. Okay, bias or error constant. Okay, and it will add it to the answer you already got, and then it will perform a function on it, which we call as the activation function. Okay, that activation function can be linear. So linear means what? You take all the answers, multiply by weight, and simple summation, and that's it. Okay, with the bias or the error constant. But there are other activation functions as well, which may give you the correct answer. So there is no fixed, there is no fixed rule for what could be the activation function. Okay, nobody has come up with this rule yet. That if the problem is this, the activation function should be this. Okay, we have used different activation functions. I will show you. But other activation functions can be logistic, hyperbolic, okay, exponential. So any of these logistic functions can be applied. Okay, or you can develop your own function. Okay, that from the answers I should be the activation function should be this. So that was a working of one neuron, and then it happens on multiple neurons. Okay, so the picture which I showed you in the last slide was for one neuron. Okay, so each neuron is doing the same thing. Then what's the difference? Each hidden neuron is going through the same process. It's taking all the answers, applying the weights, adding the bias, and applying the activation function. What's the difference? Then I should have one neuron, one hidden neuron. Why would I need 10 people like that? 10 neurons or 20 neurons? Huh?
The answer, the error.
Huh? Now why would the answer be different? For each neuron, if all the neurons are passing through the same process, then why should it be different? Yeah, sorry for that. Okay, so I have 10 neurons. All neurons are doing the same thing. Then what's the difference between having one neuron and 10 neurons? Why should I have 10 processing units? They take up space, they take up time. Okay, and because of these multiple neurons, you cannot use actually A and N in the way you can use any other function or equation or model. Why should I have 10 neurons? Every neuron is doing the same thing. It's taking the inputs, same inputs. Remember? Every neuron is taking the same input. So why should I give this input, the same input, to 10 different neurons? Why should I rely on one?
Different way?
Different weights. Okay? Each neuron will generate weights. Weights are generated. Okay? They call them randomly. That weights are generated randomly. But there are some limits and ranges which you can apply to the weights. Okay. Some criteria which you can apply to the weights. The weights should be this. They should not be less than this and greater than this. They should not be negative, something like this. Okay. But each neuron may assign a different weight to the same input. Okay. So neuron number 1 may have, so W11 means what? Weight assigned by neuron number 1 to input number 1. Okay. So 1 is this one. And 1J means weight assigned to input number 1 by neuron J. So it's the same input, but these weights are different. Okay. So since the weights are different, then and obviously the bias, the error term is also different. So because of that, they are giving me different answers. Okay. So what we are doing is we are generating different weights and we are assigning to the same input, and then we will see in the end which one of them is the best.
The optimum. Which one is the optimum?
Optimum, yeah, optimum. We will come to the criteria what we say as the optimum. So again, then the output neuron is doing the same thing. The output neuron, what are the inputs of the output neuron? The things which are coming from the hidden layer, the hidden neurons. Okay. So again, the output function is not taking the actual inputs, it is taking the outputs of the hidden layer, and then it performs the same function. Okay, so it will take the outputs of the hidden layers, it will assign it different weights, add the bias, and do some activation function on it. Okay. Okay. So why ANNs are so popular? Okay. There are some people who are against it. Okay. Dr. Hashim was. Yeah. He heard about it and said, "What are you doing?" Okay. Now he is in support of it.
Yes.
He was the one who dragged me into this. Okay. So yeah. So why they are so popular? This is mainly because of how the real world data is the numbers which I gave you, 10 numbers, I made sure that it is following some trend. They were made up. But in the real world, it doesn't happen like this. Okay, numbers are random, and then on one of the days, on one of the minutes, you will have a number which is totally, out of the range. Okay, so you can see here the numbers, for example, so you see 0 appearing. Okay, so let's say these are number of cars per minute. Okay, so you have a range from 0 to 5 per minute or per 30 seconds, whatever. So for a small time interval, this is a big range. To go from 0 to 5, 6, for a small time interval, this is a big range. But it happens. In the real world, it happens. Okay. So neural networks, usually the other algorithms we have, the statistical algorithms we have, they are very biased towards these, what we call as outliers, right? Numbers which are way out of the range. They are very biased towards these outliers. They get disturbed by these outliers. Okay, and in the end, they will not generate the accuracy which you want. Okay, but neural networks, because of their weighing and because of the biasness, they even with these outliers, so it will assign a lower weight to it. Okay, but it will still give you some answer which is usable. Like I mentioned earlier, we just don't want to be embarrassed. We know 100% accuracy doesn't exist. Okay, but it will give you answer which is close enough. So this is like rainfall data of Bahrain. Okay, yeah, it does rain sometimes. So again, now then it goes. So you see again zeros and 0.5 and so on and so forth. So and then rest of the year, like this is data for how many days? 1, 2, 3, maybe 10 days. Okay. Actual data, 10 days. But what is happening in the rest of the 350 days? 0, 0, 0, 0, 0, 0, and so on. Okay. If you take any statistical model or even any empirical model, you provide this data, the answer would be 0. Okay. This is the best that model can do. Okay. That it will take the answer which is in the rest of the data. Okay, and it will forget all these outliers. It will give you 0 every time. Okay, it happens. Okay, so neural networks. Okay, another complex problem about the traveler behavior. Okay, so we have a traveler, and there are certain things which can change his behavior. Okay, those things can be, let's say he gets a license, but he doesn't have a car yet. His travel behavior may be different. Let's say he buys a car, another change. Finds a better opportunity to work, so his workplace has changed, his income has increased, and so on. Gets married, fortunately, unfortunately. So things are changing now. Okay, so again, there's so much variation in the data. If you take any statistical model, okay, so we know all of us know regression, right? Regression model, okay. So we have like linear regression, logistic regression. So all of them have what? They have fixed form. So linear, that means I'm saying that each variable has a linear effect on the output. Okay, there is no change in that. But if a traveler changes something like this, and government changes the policy on fuel taxes, so there are a lot of changes which are internal and external. So the form of the model should change now. Okay. So it's not only about adding more data. If you add data of 100 students, and then you take data of 100 employees, they are not the same. Okay. So very often you would see that people develop different model for one category of the data and another model for another category of the data. Okay. So this is to do what? To reduce the variation in the data, because normal models will not take it into account. Okay. If you see the equations which are given for calculating concrete strength and the dimensions and so on, you did your senior in structures, right? You use this one. Some design equations. Okay, so you see with the design equations, they will always give you ranges. That this equation works from this to this range. Okay, so because after this range, the type of data will change. This form is no longer applicable. Okay. But with neural network, there's a lot of variation you can do within the model itself to take into account different types of data. Okay, so so these are the problems which we have with real world data. And if you go for their statistical alternatives, then it's a very tedious job. It's a trial and error procedure. Okay, and you have to rely on some previous information. In case of neural networks, you don't have to do any of these things. Okay, you just play with the model parameters and that's it. And these model parameters will remain the same if you give me traffic data or rainfall data, or you give me concrete strength data. The parameters of the neural network will remain the same. Okay, so I don't have to worry about new things every time I get a new data. Okay, so neural networks can be of different types. Okay, there are some new types as well, but the classical, the traditional types are three. We have linear, we have multi-layer perceptrons, MLP, and then we have radial basis function neural networks. Okay, so a linear looks like a multivariate linear regression model. A linear model, a linear neural network looks like a multivariate linear regression model. Okay, the only difference between a linear neural network and a regression model is the mechanism or algorithm for training the model. When we develop a linear regression model, okay, we calculate its weights, right? Coefficients. You know, right? Okay. So how are these coefficients calculated? What is the method behind it? What is the logic behind that? They use a specific function, right? They use a specific algorithm when they are developing these weights. I give you data and I ask you, okay, calculate or develop a linear regression model. How would you calculate the weights? There is a specific method which is used. It's known as the method of
A, B, C, forget the
method of least
square method.
Least square. Okay. With neural network, the methods are different. Okay. Least squares can be one of the methods, but there are other methods as well. And the search space, again, it can be different. The method of searching the optimum weights for a linear neural network can be different than what you have with a multivariate linear regression model. Okay. So the main difference between a linear neural network and a regression model is the algorithm of finding the weights. Okay, but the function is same. If somebody gives me, and I have used it, I will show you. Somebody gives me a linear neural network, I can extract a linear equation from the model. Very easy, no problem. Okay, and it will look exactly like a linear regression model. Y equals a plus bx plus c, y, and so on. Okay. Then we have multi-layer perceptron, which is the classical and the most commonly used neural network. The one which I just showed you was basically multi-layer perceptron. Okay. And then we have radial basis function neural networks. The difference between multi-layer perceptron and the RBFNN is the working of the hidden layer. Here we are generating what? Weights. One weight for each input. Okay. Here, for each neuron, a common centroid is calculated. Okay. So instead of having a weight for each input which is coming to the hidden neuron, we have a centroid. Okay, which is like a common number which will be applied to all the inputs which are coming to that processing unit. Okay. So if you have 10 inputs, multi-layer perceptron will generate 10 weights for each sample. In this case, it will generate one centroid for each unit. Okay, even if you give 100 inputs. Okay, so the working is different. Here and there, the working is different. While we are training the neural network, so the training or the development, the model development is known as the learning or the training of the model. Okay, so as we mentioned earlier, learning is a process, right? We input different data, so from the data it can learn what should I do next. Okay, so this is what we call as learning or training, but basically, in simple words, the development of the model. Okay, so in the development of the model, you can have a supervised approach or an unsupervised approach. The supervised approach is you are giving it some data, okay, and then you are saying with this data I got this output. So you are providing the input and the output both. Okay, so the model has to coincide with your output. So this is supervised. Yeah? I am telling you that when you get into your car, you should wear the seat belt, do this with the steering, and do this with the brakes and so on. And then I tell you, now you should drive at this speed as well. This is supervised. Okay? What is unsupervised? Like what we drive now.
I don't know the output.
Huh?
You know the input, but I don't know the output.
Yeah, I don't give you the output. I don't give you the output. Okay? So like this guy told me where to come. Okay? He didn't tell me you have to wear your seat belt, you have to drive at this speed and so on and so forth. You have to go in this lane and that lane. Okay? So this was unsupervised. Okay? So in unsupervised learning, you give the input and the model is supposed to detect the pattern or the cluster. Okay? What this model looks like. Okay? I had one thing. I can show you. I give this as an exercise. To my students, but this is just to give you an idea about what we call as unsupervised learning. Okay. See, there are some terms given. You tell me which term is different from the others and why. I'm not telling you the output, but you have the inputs, see what's the trend, and then you take out the outlier. Okay, so mashallah, the student which I had, she was very good, so she did most of them correct. She got one wrong, which basically didn't have the answer. It was my mistake. But anyways, so unsupervised is that you are feeding the data and then you are asking the network to identify the pattern itself. Okay? Okay. Then we have different learning methods as well. How the weights will be updated. We said the weights are generated randomly, right? Within a certain range, the weights are generated randomly. But those weights are not the best weights, not the optimum weights, right? So how do I make them optimum? So we apply then different learning methods. Okay. So learning methods are the methods or the algorithms which are used for looking for the optimum weights. Okay. So one of them is back propagation. So you have the values which are given by the model itself, and then you have the observed data. Okay, so the model will take the difference between the actual value and the predicted value. Okay, and then it will feed the error to the previous layers. Okay, and the previous weights will be updated. The weights which were previously taken, they will be updated, and then the model will see what was the result. So the weights were, let's say, W1, W2, W3, and so on and so forth. Okay. So when the output came, how much was the difference between the actual value and the predicted value? Okay. So let's say the difference was 50%. Okay. Let's say. The model will take this error, feed it back to the previous layer. The previous layer will apply some search function to generate the new weights. Okay, and then the output will be generated again, and the model will see what happened with the output. Did the error increased or decreased? If it decreased, good. It will keep on doing this. If it increased, then it will go in the other direction then. So for example, it tried increasing the weights, now it will try decreasing the weights. Okay, so this is what we call as the back propagation method. Okay, so like I said, this is the error, and usually take the square of that. Okay, and then the error is fed back to the previous layer, and we are trying to minimize this term basically. Okay, we are trying to minimize this term. Okay, so back propagation is the most commonly used algorithm for the learning method. Okay, there are others as well, but you can go through them. Obviously, we don't have the time to go through each of them. There are many. Okay, but this is the most commonly used method, and this is the one which I have used in like 90% of my research. Other variations which you can have within the neural networks are the activation functions, which I already mentioned, right? You can have a linear activation function. So activation function means what? What you are doing with the summation, right? We have summation of the inputs, right? So what do you do with the summation? Are you adding them linearly? That will be a linear activation function. If you take the summation and then you take you apply the sigmoid function on it, so sigmoid is your activation function. Okay, so activation function is when you take the inputs, how do you process them? Okay, so you can have linear, you can have sigmoid, you can have bipolar, you can have ramp, and you can have hyperbolic, and so on. Okay, any trigonometric function you can think about, you can apply. There's no limitation. Yeah. So then these are the different learning methods, the search mechanisms basically, how the weights are searched. Okay, so like I said, you had one set of weights and it is giving you an error of 50%. Okay, so how should I devise them? So there are different methods. Okay, if any of you takes a course in artificial intelligence, they will tell you about search methods, different search methods. I don't know, maybe some of you have already taken it. No?
I took in your network course.
Uh-huh.
You use the first one.
The first one, the conjugate is, yeah, this is the most common one. Okay, so you are going along a particular gradient, right? You go up and down, but along a particular gradient. Okay, and so on and so forth. So,
excuse me, also back propagation like this?
you can use them with back propagation, yeah. Because they are the methods for searching for new weights. Back propagation is the method for, or the mechanism for feeding the network. Okay, so once the error is fed, how the new weight should be calculated. So it will be according to one of these methods. Okay, and then you go again forward, and then you recalculate the weight, and then the error will be fed back. Okay, so the method is still back propagation. Okay, another good thing with neural networks is you can have multiple outputs. This is very uncommon. You will not find it with any other thing. Okay, so neural network, you can have a single output which is for forecasting or function fitting. Okay, you are trying to find out a function. Okay, or you can have multiple outputs. Okay, so for example, you are using neural networks for mode choice. So you have different choices, right? Okay, so the neural network can tell you probability for each choice. Okay, and you have, for example, if you are doing unsupervised learning. Okay, so the neural network can give you different clusters of data. Okay, so there can be multiple outputs. Okay. advantages of using neural network, like I mentioned earlier, you don't need any previous knowledge about the data or the modeling problem you have. Okay, I don't need to know if the input is material properties or traveler characteristics. Neural network for the neural network it's the same. Okay, you will still play with the same parameters, number of neurons, the weights, the activation function, and so on. Okay, you have the same choices. It can work well with the small data sets. There's usually a big problem with experimental data. Okay, because experimental data, then you need effort and you need material and so on. Okay, so then it is very helpful to work with neural networks because of its structure, it is it's just taking output from different units, right? Okay, so even with the small data, you are still covering a large range of possible outcomes because each unit is giving you a different outcome, right? So the range of possible outcomes is still very large. Do not require filtering of variables. This is again very problematic. Okay, sometimes you have like 10 variables. You have tried to apply the statistical model, and the statistical model have these constraints. The p-value should be this much, the coefficient should be significant, and so on and so forth. Okay. So sometimes it lands you in a very difficult situation. We did one paper with for value of time. Okay, and this is very unique in Saudi Arabia and Bahrain. You calculate the coefficients for travel cost and time, and they come out to be positive. Okay, like in other countries, they should be negative. But for some reason, travel cost and travel time have a positive effect on people who are choosing car or something. Okay, we saw that. So if you are using a statistical model, it will not be accepted. Okay, but the network can accept this. It can cater for outliers, like I said, it will assign it less weight. Can generate multiple outputs, like I showed, and prior knowledge of the variable itself is not required. The variable itself, which you are using, okay, is it normally distributed? So, for example, when you are using the logic regression, okay, there is an assumption behind the variables. Okay, the variables have this form. Okay, even with linear regression or multiple regression, the values are supposed to be normally distributed. In neural networks, there is no such restriction. Okay, so now I will give you some examples where I have used neural networks. Okay, and then there can be others as well. One of the examples was forecasting traffic and travel behavior. Okay, we did it for causeway. Okay, so I will just give you the examples which are related to traffic and traffic and travel behavior. Okay, but I have used it in some other fields as well. Okay, and you can ask Mr. Saad there. We did a paper which was related to what?
Prediction of strength of concrete.
Strength of concrete. Okay, so there are other fields as well in which you can use it. Okay, so we use neural networks for traffic prediction on the causeway, the King Fahd Causeway. Okay, so the data which we had was basically the time series data of traffic counts which were taken on different days. Okay. Okay, so what we did was first of all we applied the data without any classification. The total data just fed to the network, and the network should give us the output. Okay, and then we said, okay, fine, let us try something else, and then let us classify the data. Okay, so traffic counts of the people who are locals and traffic counts of the people who are expats or from some other countries. Okay, so then we classified the data. Okay, so then we used the classification as one of the variables in the model. Okay, so there was one model which was just taking traffic and giving us output, and then there was another model which was taking traffic and the type of traffic, is it local or coming from somewhere else, and then give us the output. Okay, so obviously, and we tried using different neurons, processing units, and we tried using different learning rates. So I told you about the weights, right? So, for example, the first weight with the network generated was 1, and the error was very high. The next weight, how different it should be from the previous weight. Okay, that is what we call as learning rate. Okay, the rate at which the weights are changed. So the first one was 1, the next one will be 1.01. Your learning rate is this one, and so on. But if you reduce the learning rate, then the processing will increase. Okay, so you need a lot of time for that. Okay, so now you can see here one thing goes up and then down and then up again. Okay, same thing here. It started to go up again. Okay, so there is an optimum point where you need to stop. When you're using the neural networks, okay, you have to optimize everything basically. The number of neurons and the learning rate and so on. Okay, because if you don't do this, if you just see, okay, now it's going down, let me just keep on reducing the learning rate. You may end up on this side. Okay, and again, this changes from one problem to the other problem. Okay, number of iterations and so on.
Do we have to care about the interaction effects between them? Maybe we get the optimum with one parameter, then if I use that optimum parameter to check maybe the number of hidden neurons, I will get negative result. How should you care about this or we don't care?
Interaction of the variables, the input
Between
variables.
them, maybe you found the optimum parameter, like learning rate 0.1. You tried that one to check the number of hidden neurons. You get 150.
Yes.
And
Yes,
maybe
there
the
is.
error increased.
Yes.
So what to do in this case?
There is an interaction effect.
There
Yes.
is.
There is.
So how to optimize this parameter if you have such things here?
Normally what I do is I fix one of them if I have to do it manually. I fix one of them. Okay, try to find the optimum for the other one and then play with the other one, the first one. Okay, this is what I do. But now there are softwares available which take some time and they do it.
Yes,
They are.
And there is like in Python, it's called the grid search CV. It's like tuning. You put parameter, like range of parameter, like neuron from 1 to 20, and
Yes.
learning rate, many learning rates. So it tune in all of these parameters and give you best or optimal model or optimal combination of parameter.
I use Statistica, it does the same thing. Yeah. Okay. But then you are relying completely on the tool itself.
Yes.
Okay, so these are the different models which we use: linear regression, MLP, RBFFN. Okay, and the best one was, so you can see the neural networks, their accuracy is very close to each other. Okay, so this is their error basically. Okay, so the error for linear regression was very high as compared to MLP and RBFFN. And for this case, both types of neural networks were almost the same. You can see there's not much difference between them in the accuracy. Okay, so in this case, they were very similar. We also applied ensemble learning in one of the other research problems. We also applied ensemble learning. What is ensemble learning or ensemble? You take different models, you join them together, okay, to process the same output. Okay,
It's like
so,
voting or
yeah.
take vote from each one and
Yes.
ensemble one.
Yes. Okay, but ensemble, then there should be something different between each model which you are joining. Okay, like within neural network we have an ensemble, right? With each processing unit, there's an ensemble. I'm not talking about that. Okay, so ensemble means that, for example, you take one neural network which is trained with one data, and then you take another neural network which is trained with another data, and then you join them together. This is normally what we call as ensemble. Okay, if you are just taking different similar networks and just joining them together, it's just like you are increasing the complexity of your model. That's it. You are just adding one more layer. Okay, we don't call it ensemble. Ensemble means the models which you are joining, there should be something different between them. The data or something different between them. Okay, so in this case, now you can see here, models were same. The difference was the data. We were using time series data, but this model was only taking data for previous 1 day. This one 2 days. This one 3 days. So you see, number of variables are different. This one has only one variable. This one has 2 variables. Okay. So when you join them together, that's an ensemble. Okay. So they use one of them. Okay. So these are the results, okay, and what we also tried was, this was from Dr. Nidal's, Dr. Nidal's, mind, that brain, that why not we use stock market indices as a predictor for border traffic, because it's a border, right? Okay, so border traffic depends upon political situation, economic situation, and transport. Okay, and so if you try, how do you measure political situation and economic situation? So the measure we introduced was, or he introduced was, stock market indices. So when he added traffic data with the stock market indices, time series data, the accuracy was much better. Okay, in all cases. Then we applied neural networks for mode choice behavior. Okay, for mode choice, basically we use another type of neural network which we call as PNN. Okay, probabilistic neural network. Okay, so that's a very specific network, or that's a very specific type of neural network which gives you the choices. Okay, it is the architecture of the model is specific for modeling the choice behavior. So in the end, the answer which it is giving is not a continuous variable, it's like the choice. So the answer will be 0, 1, 2, something like this. Okay, so the three choices, the model will tell you the user is taking which of the choice. Okay, so for mode choice, we have a specific type of neural network which we call as probabilistic neural network. So we apply different scenarios. Okay, if we have a car, if we have a ferry, at that time Dr. Nadal told me that they will start these things very soon. I am still waiting. Okay, we applied another type of ensemble for mode choice. Okay, so I already told you about one ensemble, right? With time series data. This was for mode choice. Okay, so we developed a logic model. So with the logic model, we have weights, right? The logic model will develop a utility function. The utility function will have some weights. We took those weights as the input. The probabilities. The logic model gives you probability for each mode choice. 50% for car, 30% for bus, and so on. We took those probabilities and we fed them as input into the neural network. Okay. So the first model was logic model. The second model was neural network. Okay. And the input for the logic model were the variables: travel time, cost, gender, income. Okay. And the input for the artificial neural network was the probabilities which are generated by the logic model. Okay. So we were basically refining the output of the logic model using the neural network. Okay. And we got, alhamdulillah, good results in the end. These are the conclusions which we had. Okay, so NN gives better accuracy than the logic model, and if you apply the ensemble, then ensemble is more accurate than the other models for multinomial cases. If you have a simpler problem, this is another thing. If the problem is simple, okay, and you have enough data, then you don't need to go for complicated models. A simple, maybe logistic regression or linear regression is enough. Okay, it will give you enough accuracy and it will make your life easy. Okay, so if your data is Gen 1 and the problem is simple, don't go for these models. Okay, they will not add any value. Okay, and the first argument will be why did you go for this model? Okay, you are only predicting 0 and 1. Why do you need a neural network or something like this? Okay, so that ensemble was very good when we were using the multinomial cases. Then we used neural networks, the function, the weights from neural networks to calculate VOT. VOT is value of time. You know about value of time, right? So in this case, we used linear neural networks. So linear neural networks looks like linear regression, right? But I told you the method of finding the weight is different. So it is much more advanced than linear regression. Okay? So we took the weights from linear regression or linear neural network and the weights for cost and time. Okay, and then we can use them to calculate the value of time. Okay, so the weights can be used. If you can handle the weights, they can be used. I will tell you one more usage of the weights. So these are the value of times which we found for different data sets. Okay, pool data means the complete, and then we have for each type of traveler category as well. We used a neural network for doing the analysis for small data sets, especially for road safety problems. So there were some very small data sets from a few intersections in Malaysia. Okay, the data set was very small, 20-30 values, not more, 20-30 samples. Okay, so obviously with this amount of data and road safety, so a lot of variables, road design and type of accident and so on. This data and this many variables. Even if you try to build a model just for the sake of explaining the relationship between the data, it was not good. Okay, so we tried, regression model, and we even tried. Usually, what we do, if you have a small data set, 5 samples in each case, what we do, if you have to compare between the data set, if you have to seek a trend, okay, what is the trend of the data, then we apply statistical tests, t-test, ANOVA, okay, they can be applied very easily. They cannot give you the weights and coefficients and models, but they can tell you about the data. Okay, this one is higher than this one. When you increase this variable, the output increase or decrease, and something like this. Okay, they can be very helpful with that. But with so many variables, they don't work. We have 10, 20, and 15 variables, and you are trying to apply ANOVA and t-test. By the time you reach the end, you don't know what does it mean. Okay, so we needed a single model which can at least forecast, and the weights can be used for finding out the trend or the relationships between the variables. So this is why we used neural network for our road safety problem. Okay, this is what, yeah.
What about the percentage of growth and which factors will affect? And you get the data from the actual, right? And what about the growth, the percentage? How you get the specific percentage of this for the future?
For the future, yeah. For that, then you should have data from multiple, time spans. Okay. If the network has enough data which was growing, then even it will work for the future as well. Okay. For example, the time series data. If I give time series data for only 1 month, and I'm using it to predict a value which will be after 5 years, it will not work. But I give you time series data for years, and then I say, okay, after 5 years, if this is the input, what will be the output? The network should give me the value, because the network by default should not have any range. It should not have any limitation. Okay, got it?
Like a range, you have to put like a range, the percentage.
The input data which you are putting, okay, should be enough that if the network wants to go so far in the future, it can do that. Okay, so you want to go 5 years later, then your input data should also be like 5, 6, 10 years later. Like the input data which you are giving him should also be cover that span. Okay, otherwise the network will give you some answer. Okay, and that answer will be reasonable, but will not be that accurate.
Of course.
But if you give enough data, then maybe the accuracy will be high. So the network should take into account the growth rate as well, but only if the input data has enough range, enough span. Okay, this was done by actually Dr. Ndal and Dr. Khalid Asif? Okay, so this was basically done by them. Okay. So lane utilization factors, right? Okay. So they have again one application of AI is dynamic lane assignment. So you have lane assignments when you're coming to the intersection. You have different lane assignments. Okay. This lane for right turning, this lane for left turning. So in some countries, I don't know about here, it's not in Bahrain yet. In some countries they have dynamic, so they will put these electronic boards. Okay, so every hour you may have, for example, now 2 lanes for left turning. After 1 hour, they have only 1 lane for left turning. So this depends upon the volume you have, how much volume you have for each turning movement, okay, and the signal parameters. Okay, so if you use the regular method, okay, and this is the words from Dr. Aziz actually. If you use the regular method to calculate the new assignments for the number of lanes you should have, there are so many variables and the process is very long. So the processing power you need with the signal, okay, or with the electronic boards which is operating is, is more. So using neural networks, they came up with a very quick method of assigning these lanes to different movements. Okay, so so basically the variables were the volumes you have, number of lanes you have, okay, and the signal parameters, the yellow time, the red time, and so on. So you are you see now you are optimizing signal timing as well as lanes. Both are changeable, right? They are changing from 1 hour to the other hour. Okay, so with so much variables, if you apply any other method, then you have to do what I just mentioned for doing the learning rate and number of neurons. You have to do it one by one. It will take a lot of time. Okay, so they developed a neural network which can do this, from the start. So I use neural networks for material testing and material forecasting as well, material characteristics for forecasting. Okay, so the main problem with materials is, okay, what I have found, they are introducing new materials. Okay, so the characteristics are changing. So the standards and equations which they already have, they don't work. If you perform any laboratory tests, okay, so they will tell you the conditions of the experiment should be this, and the answer will be in this range, the input should be in this range. All these things are not applicable now, because you change the entire property of the material. You introduce something new. It's not at all the same thing. Okay, so with these new modifications, where are the equations? Then you go back to the same process again. So those equations which somebody developed after 50 years of research, now you have to redevelop them. Nobody has that much time. So again, neural network provides you a quick method of predicting the material properties using the new variables with the new characteristics without much data. Okay. So you can use it for updating the. So in this case, they updated the type of. So it was about asphalt aging. They were using some testing with the asphalt sample. So they modified the asphalt. This was one of the problems. And then they also modified the the equipment which they were using. So they were using carbon nanotubes. Okay. Obviously, there are no equations and no ranges which apply to carbon nanotubes. Okay. So then we have to use neural networks, or we need to update. Okay. So either you generate that much amount of data which was used for having those equations, or you come up with a easier, more efficient method, which was neural networks. Okay. So I had just towards the end, there are some of the results. We had good results in the end. I had a student group in Pakistan. Pakistan, we are very imaginative, creative. Okay. So they had to submit their project tomorrow, and it was this time. Okay. They came to me, they did the experiments at the whole year. Okay. Then they came to me, their graph was horrible. Like I said, when you do the experiments, they give you, the trend should be this. Huh? So they came to me once and twice and thrice. Then they said, "Doctor, tell us what the graph should look like." And I was obviously fed up with them the whole year. I showed them in the book. The graph would look like this. 4 p.m. They went to the hostel. 4:05, they called me. "Doctor, we are done. The graph now looks like this." I said, "What did you do?" There was a problem with the scale and what are the problems? Okay, so everything is not good with neural networks. They have some problems as well. Lack of explanatory power. When you have an equation, it's easier to explain the relationship between the input and the output. This one has linear relationship, this one has positive effect, this one has negative effect. But the same variable has 10 different weights. they have come up with some methods to find out the relationship even using the neural network. But in all of them, the problem is that you need some extra calculations. Okay, so you are trying to save the time, but if you are trying to get more, extract more data, extract more insight from neural networks, then you have to do something else. Okay, for example, one of the methods which is very easy, stepwise method. Now I want to see which variable has more effect, which variable has less. So what would I do? I will use one variable at a time. So if I have 10 variables, I'll generate 10 models. Then I'll compare between the average. Okay. So you see, instead of one model, you made so many. Okay. This is one of the methods. The other method is you go for integration of the errors and the derivative of the weights and so on. Okay. So these are all different methods, but the common thing is it will not happen without some calculations, like extra working, extra analysis.
So using this method, you can explain the result.
Yes.
Why some still people don't trust if you use such models in prediction or whatever reason, how you explain your good result for example. So this method can be used.
Can be used. Okay. But they need extra processing, and again, the weights are not in your control. Like what I was mentioning for logistic regression, we got negative sign for cost and time.
So these method will explain the weights.
The weights, yeah.
And if you explain the weights, you can explain the relationship. That's what you're saying.
Yes.
So the artificial intelligence becomes not a black box.
Yes.
It has some meanings. That's very great.
The problem of local minima, which I showed you with the learning rate, you may get stuck at a point which is not actually the optimum point. If you had gone further, you would have seen other results as well. So what we do to avoid local minima, you can normalize the data, normalize all the variables, provide a bigger data set, apply cross validation. Okay, so use one data set, train the model, and then use another part of the data set and then again train the model. Okay, so we call it cross validation. You can use ensembles. You two different models. Okay, so if one model has a problem of local minima, the other one hopefully will not. Okay, or you can use a neural network with fuzzy inference system. Okay, so this again an ensemble of neural networks and fuzzy logic. Okay, this is another broad topic then. Other problems which we already mentioned, I think. Okay, how many neurons, what activation function you would use, okay, so these things, and what input variables you would use, because neural networks will not give you anything when you are feeding the data, okay.
But the first two, considering us as traffic engineers or researchers, should we care about these things, or we should care about how to build the problem itself, how to select the related variables and so on? In building the networking tapes, for example, the design of the network itself. You know, using, as I think Hussam said, that like in Python, it will do it for you.
Yes, good.
So should we? It's important to, for example, I understand what is the activation function and how to work and how it's related to my problem.
Yeah, sometimes it can help. Sometimes it can help. You can reduce a lot of your time if you know what activation functions are giving you the best answer, and then you can try to make some use of it as well, like we did with the linear neural network. You can fix it because now I know I need to use this in the end. Okay, so I will extract it and fix the function, and then I use it for something else. Okay, you can do it. But if you are doing it for this is how we started with Saad, that he told me that some people in the industry are using neural networks to predict concrete strength. Industry people, they don't care. What is the relationship? Okay, these are the input, this is the output, and the output is 98% accuracy, that's it. Okay. So for industrial use, you don't care. Okay. But for us, researchers, it is different. Usually they don't, this is the biggest argument which they have. How are you sure that this variable actually works? Neural network is easy, but how are you sure that this variable should be in the model? And so on. So then for that we need some extra processing and so on. Okay. So what are the latest trends? We have now recurrent neural networks. Recurrent means neural network, each unit in the neural network has its own memory. Okay, so within each unit, it is trying to optimize itself. Okay, so if it had a problem with one of the variables, next time you give him some data, it will not start working from zero. It will learn from previous experience, and with the new data, it will start from there. Okay, so we call it recurrent, meaning the variable itself is taking, the processing unit itself is thinking about what should I do next. Okay, deep learning neural networks, big field. Okay, taking everybody by storm. Okay, all the fields, image detection, speech recognition. Okay, so all these are basically different applications of deep learning neural networks. In deep learning, you are increasing the number of processing units. Okay, and then you need a lot of data as well. And why we need to increase the number of processing units? Because we need to identify, or the network needs to identify each and every single variation in the data. Okay, so for example, when I was making my passport a long time ago, they used your picture from the system. Okay, and then they said, okay, give me a new picture as well. I put on the passport. I gave them the new picture, and they said your picture, which is in the system, doesn't match. Okay, and I asked him, who will check this? They said the system. I said, take it. The system is, intelligent enough to see it's the same person. Okay, so this is basically one of the examples of deep learning. Okay, so the network is so deep that even minor trends are identified. Okay, now we have these applications. You give them a message, and they will like a person will say your message. Okay, and the way they are saying it is better than you actually. So these are some of the examples. You see the surveillance we already mentioned, Google Translate. So it doesn't ask you which language is it. It will detect it and give it to you. Okay, but so many languages. Okay, but it will detect it, and some of these languages are very similar. Okay, then we have this new thing, ChatGPT. Somebody used it? No?
We heard about
Have
it.
a look. People are posting videos. Have a look. Okay. And in Google you put a wrong spelling, and then it will give you like, instead of east, it will give you answers from west. With this guy, there is no problem. Okay, so like if you, instead of KFUPM, if you write MUPM, it will still detect it that he is talking about a university. There should be this one, and this is the data and so on. Okay, so this is another example of deep neural network, deep learning. Okay, because you want to capture all the variations. Okay, so, but the problem is the network size is increased, and the second thing is we need big data. Okay, what you were mentioning. Okay, you want to predict 5 years later, then the data which you gave should also be for the last 5 years, so that the network knows what will happen after 5 years. Okay, you want to say the network should be able to identify all the variations in my face, then you should give him enough images to detect what variations happen with age and time and so on and so forth. How a person would look like with a beard, without a beard, with hairs, without a hair, and with a cap, without a cap. You should give him all these variations. Okay, so but
regarding this, is there any procedure or method to tell me how much, let's say, observation or data needed to accomplish this problem? For example, the example of the face. How many pictures are enough to the model to get labeled?
maybe there are some thumb rules, but I'm not sure. Okay. In the end, you have to look at the accuracy. You have to look at the accuracy. Okay, I provided him 50,000 images, and the accuracy is on the calibration. The validation data set is, let's say, 15%.
Okay.
Okay, is it enough for me, or should I increase? So I did not hear about any thumb rules. Maybe there are. Okay, but I did not hear about. But the good thing is we have big data. Okay, the papers on which we are working right now is the big data from which we have traffic data from 5 different countries. Okay. So these countries, developed countries, they are putting their data online.
Yeah.
Even for Causeway, we have the data online. The stock market indices, they have their data online. If you go there, you will find millions of ones. You can use it. And if you have access to cell phone data, social media data, which these companies have, so they are using it. Okay. If you can get access, the data is there. Okay. Processing capability increased, right? Processing capability has increased greatly. Okay. So now you don't have to worry about if you apply a deep learning network, I will have to wait for 3 days. Okay. It will work. Data collection. Now we have more efficient methods of collecting data. The hardwares which we are using, the equipments which we are using are more efficient, and then we have these tools which are generating the most efficient network for me. Okay, so I don't have to do everything manually. Okay, so this is it. Sorry for taking your extra time. Okay, so thank you for listening. If there is
Thank you very much for the input. I really like it. I wish I could spend more time with you, but I have to run to one special activity. But I really appreciate it, and it's very great presentation. If you allow us PDF version with your name on it, no problem. I'd like to post it for my CV. I will be calling you tomorrow.
yeah. Any questions from you?